So for this question, we are asked to identify equivalent and equal sets. So the real key there is knowing the definitions of equivalent and equal. So before we do anything else, let's just remember something. Equivalent sets have the same number of elements. Equal sets, those have the exact same elements. So equal sets are truly the exact same set. Equivalent sets just have the same number of elements. So if two sets both have 5 elements and one is A, B, C, D, E, and the other is 1, 2, 3, 4, 5, just as an example, then those would be considered equivalent sets. So this first one, set A is the set of integers greater than 16 and less than 20. Set B is the set of elements 17, 18, and 19. Well, so I mentioned this in an earlier video. When you have a set that's described verbally, one of the most helpful things to do is just write that set in the roster method, even if you don't write all of it, but just writing part of it to help you understand what exactly are we talking about here. So if we think about the set of integers, remember what integers are. Those are the counting numbers, positive and negative and 0. And so we want those integers that are greater than 16 and less than 20. So greater than 16 means starting with 17 and count by 18 and then to 19. But to stay less than 20, I've got to stop right there. So if you think about that set and then set B, turns out they're exactly the same thing. And so they are equal. So then you look at this. One mistake to make would be say, oh, they're equal but not equivalent. Well, actually, they're equivalent because equal sets are always going to be equivalent. So it will never, ever, ever be this answer, by the way. So that, in fact, this one, I got to find my eraser. Where'd the drawing tool go? There we go. Draw, get my pen out. Why it's not letting me erase that circle, but it turns out to be this one, both equivalent and equal, because equivalent just means they both have 3 elements. Equal means they're the exact same 3 elements, so 17, 18, and 19. So that's this first one. Part B, you're looking at the set of even integers greater than 1 and less than 7. So again, you see this verbal description. First thing I do is use the roster method to kind of write this out. Even numbers, so even numbers, so that's 2, 4, 6, 8, 10, that kind of thing. Even numbers greater than 1, less than 7. So 2 is greater than 1, 4, 6, and if I write 8, I'm like, oops, it's got to stay less than 7. So erase that last comma or just kind of turn that into a curly brace. 2, 4, and 6 is what we're talking about. Here, part B, the set of integers greater than 5 and less than 9. So greater than 5 would mean start with 6 and 7 and 8, and then to be less than 9, I'd have to stop there. So that contains 3 elements. Set B contains 3 elements. And set A also contains 3 elements. So they are equivalent sets, but they're definitely not equal because they're not the exact same elements. Part C is going to be the same thing, equivalent but not equal. Equivalent because this contains 4 elements. And this contains 4 elements. So equivalent because they both have 4 elements. Not equal because they are not the same 4 elements. So that's that one. D That's going to be the one that's neither. It's nothing. This has 3 elements. Set A has 3 elements. Set B has 4 elements, and they're not the same. So this was the one that is neither equivalent nor equal.